Bismillahirrahmanirrahim. Assalamu alaikum everyone. We are H.A.S. Today we will be demonstrating the operational characteristic of common collector amplifier and to investigate what influences its voltage gain. It is called common collector amplifier because we know for DC analysis capacitors and DC sources will be short, so when this DC voltage source is short, then we will see that the collector of BJT is directly ground, so that's why it is called as common collector. It is also called as emitter follower because we can see that the input is given at the base of BJT, but the output is always taken from emitter of the BJT, so it is called as emitter follower. In this circuit, the output is never larger than the input, but is always in phase with the input. So without wasting our time, let's start. I will make this circuit again for you, but to show you what it does, I have already made it. Let's just see what it does. You can see that the green is our input and the red is our output, and we can also see this from here that the green is input and the red is that of output. The graph shows that the peak of the green wave is always greater than the red. The green peak wave is always greater than the red. This is because we have made the circuit that is called as emitter follower, and its voltage gain is always equal to or less than 1. So output will be slightly less than input. So let's make it again. Select create project, name it whatever you like. I will name it 5-8. Select create the new project. Now this window will appear. First thing we need to do is to create a new simulation profile. Name it whatever you like. I will name it the same as of my project name, that is 5-8. Alright, now first we have to set some settings. This will be 100 milliseconds, that is runtime, that is the input and the output are compared for 100 milliseconds, and the input is taken after every 100 microseconds, and it will run till 100 milliseconds. Alright, we have to select our components. PSpice components, passive components, go here. This is R for resistor, capacitor for C. They are represented by R and C. For discrete, here it is NPN, BJT, and sources are voltage sources. This is DC source, and this is sinusoidal AC source, that is represented by AC, sinusoidal and DC. We will use them in our project. We will tell you later that what is the purpose of this. Now we can also select our components from here. You can place capital R for resistor, capital C for capacitors, VDC for DC voltage, and V sign for AC sinusoidal source. Alright, we can also place 0 for the ground. Ground is also present here. You can see that PSpice ground is here. For components, we can also go here. This is place part. You can select the components from the here. write R for resistor, that is R analog. For capacitor, select C, that will be C analog. VDC for the DC source, and V sinusoidal for V sin, VSIN. If these options doesn't appear, you can add them from the library. You can select them from here, or such like these sources, or select these all libraries, then select open, that these all library will appear here, or you can add here any component from here. Let's start. That is our first component, that is sinusoidal source, voltage sources, sinusoidal. Here it is. For resistors, go here, select resistors. You can also rotate the resistors by pressing R. Third, this is the fourth load resistor. Now for voltage VDC source, it will appear. Also rotate it. Here it is. First we have to place our NPN transistors and capacitors also. Go to NPN transistor, select it, place it here. Now capacitors, that are coupling capacitors, select capacitors. This is first coupling capacitor, and this is second coupling capacitor. Alright, now we have to place the ground, that is PSpice ground. This is for whole circuit, this is for AC source, and these are for resistors, and this is for VDC. Alright, we have to join them quickly. Just connect them. Be sure of your connections. So I am joining it again. Now we are joining this coupling capacitor with the emitter. This is with the load resistance R, load resistance with the ground. We are grounding the whole circuit. Now AC source, and now this DC source. Alright, the most important connection is the base of this BJT. Now simply we have to give values to all to the components. Now this is 22K. This is second resistor. It will be of 27K, 27 kilo in simply words. This is the third resistor. It will be 2.7K. This is our DC voltage. Its amplitude will be 15 volt. Now coupling capacitor is 10 microfarad. This will be 2.2 microfarad. V offset will remain 0. This is V offset. It will be 0 always. Now this is V amplitude. This will be 10 millivolt. Frequency will be 100 hertz. That's all. We have to put our probes. This is the input probe, this is the output probe. I know that. Again, I will connect the ground with the DC. Connections should be very proper, otherwise you will not get the correct waveform. Things like this will happen. Now it is connected. Now it is connected. These voltages are appearing. Now the voltage probe, first voltage probe and second voltage probe. Now I will run. Yes, it's 100% correct. You can see that the green is input and the red is of output, and red is output slightly lighter than the input. This is the characteristic of common collector amplifier. Thanks for watching. Don't forget to subscribe the channel. Thank you.
Guys, don't forget to subscribe down below and also give this video a big thumbs up, and don't forget to comment down below the dark.